graphs, I'd be more than likely looking for the area between them. There would be intersecting graphs. Yes? We call this f of x, and that will be g of x. And I'm looking for the area bounded between them. So if I give you intersecting graphs, the first thing you would be expected to do is sketch. And the second thing you'll be asked to do is find the points of intersection. Sometimes you may do this first because it helps you to draw your graph. So now once I have sketched it and found my points of intersection, well then I now have my limits of integration from A to B. How do I work out that integral? Well, do you understand this? That the bounded area is the integral from A to B of g of x dx minus the integral from A to B of f of x dx. And do you understand that that's the bounded integral? When you do the g of x, you get the area between that curve and where? The x-axis. So you get all of that. Yes? When you do the straight line, you get the bottom bit. And when you integrate, what you're getting is the area from the curve all the way as far as the x-axis. And then it's one minus the other. Very good. Y is equal to x squared intersecting x equal to y squared. Right? So you have to work out the area bounded between those two curves. Y equal to x squared intersecting x equal to y squared. Yeah? So you sketch them. Alright? So sometimes it's not that easy sketch because you haven't sketched heaps of those in your time. Y equal to x squared. If you remember that graph, x is 0, x is 1, x is 2, 3, minus 1, minus 2, minus 3. Y is equal to x to be squared. When x is 0, what's y? 0. When x is 1, what's y? 1. When x is 2, what's y? When x is minus 1, what's y? And when x is minus 2, what's y? There's the graph y equal to x to be squared. Y equal to x squared is symmetrical about which axis? The y-axis. X equal to y squared. Right? I take the y values first. When y is 0, what's x? 0. When y is 1, what's x? 1. When y is 2, what's x? 4. Be there. Yes? When y is 3, what's x? 9. When y is minus 1, what's x? 1. When y is minus 2, what's x? 4. So that's that graph. In other words, it's symmetrical around that axis. Now, why isn't it identical looking to the other one? It's because I have a different scale on each axis. But the area, the bounded area I'm looking for is in there. That's the area where they intersect. Do you understand that? So if I magnify the diagram in that area there, x is 0, x is 1. That's which graph is that graph? X equal to y squared. And there's the other graph. And what graph is that? Y equal to x squared. And that's the bounded area. So the area then is the integral of the top graph of y dx minus the integral of the bottom graph y dx, which is the integral. I'm integrating from 0 to 1, x equal to 0, x equal to 1. If that's the graph y equal to x squared, what's y equal to? Root x dx minus the integral from 0 to 1. If that's that graph, what's y equal to? X squared dx. That'll give me the area. Yes, because from this graph it's the y squared is equal to x. What's y? You don't want to talk. Fair enough. Root x. You understand where I get the root x and the x squared from? Could you have found that point of intersection algebraically? You could. Y equal to x squared and x equal to y squared. So x is equal to y to be squared, right? So instead of this x, what could you have called it? You solve that, it doesn't matter which one of them you sub into. Just let me do. Y equal to x squared and x equal to y squared. So what does y become? X to be squared. So x is equal to x squared to be squared. X is equal to x to the power of 4. X to the power of 4 minus x is equal to 0. That's x outside of x cubed minus 1 is equal to 0. So therefore x is equal to 0 or x cubed is equal to 1. X is equal to the cubed root of 1, which is 1. So where do they intersect? At 0 and at 1. So I could also have done it algebraically.